How does water's density anomaly work? Have you ever wondered why ice floats on water? This fascinating behavior is tied to water's density anomaly. It is not just a quirky trait, it has significant implications for our environment. Let's break it down. Water behaves differently than most substances when it cools down. As it drops to about 4 degrees Celsius, it actually becomes denser. But once it goes below this temperature, it starts to expand instead of contracting. This means that water reaches its maximum density at approximately 4 degrees Celsius. As it cools further toward freezing, which is 0 degrees Celsius, its density decreases. This unusual behavior stems from the molecular structure of water and the hydrogen bonds between its molecules. When water is warmer, the molecules move rapidly, and the clusters they form are unstable. As the temperature decreases, the motion slows down, allowing 4 stable clusters to form. These clusters have a more open arrangement, which is less dense than the compact structure found at slightly higher temperatures. This change in arrangement causes the volume of water to increase below 4 degrees Celsius, leading to a decrease in density. From a thermodynamic perspective, the balance between attractive and repulsive forces between water molecules plays a key role. The soft repulsive forces at very close distances, combined with the hydrogen bonding network, create conditions that change the internal energy and structure of water. This results in negative thermal expansion below 4 degrees Celsius. This density anomaly is not just a scientific curiosity. It has practical consequences, especially in freezing and aquatic environments. Since ice is less dense than liquid water, it floats. This floating ice forms an insulating layer on the surface of lakes and ponds. This insulation helps keep the water below the ice in a liquid state, allowing aquatic life to survive during winter months. The fact that the densest water is at 4 degrees Celsius means that colder water remains on top while warmer water sinks. This layering effect is critical for many natural processes, including nutrient cycling and temperature regulation in aquatic ecosystems. In summary, water's density anomaly is a remarkable phenomenon that arises from its molecular interactions and hydrogen bonding. It causes water to contract until it reaches 4 degrees Celsius and then expand as it cools further. This behavior is essential for life and environmental stability in cold conditions, linking thermodynamic principles with phase changes and freezing phenomena.